Hi everyone, welcome back. Today we're doing day 10 binary numbers. To be specific, we'll be learning how we can express decimal numbers or base 10 numbers as binary or base 2 numbers. So in this case, after converting that into that representation, we are supposed to do some form of scanning through this string to figure out what is the maximum number of consecutive ones in this n binary representation. And once we're done, we'll be printing this number out as a base 10 number. So for example, we're given 125 in base 10. Then that can be expressed as 5 consecutive ones, followed by a 0 and a 1. So in this case, because there are 5 consecutive ones, we will print out 5 as the maximum number of consecutive ones in this binary representation. Notice that the input range from 1 to 10 to the power of 6. That will be important for us later to figure out how many bits we need to express this n. And this input, in this case, the first line is the n itself, which is the base 10 number that we have to read in and convert into a binary representation. The output, in this case, would be the maximum number of consecutive ones as we discussed. So that's pretty much it for this question. Fortunately for us this time, HackerRank is really nice to give us the boilerplate to read in the input, and as usual they use the getLine function to read in the first line from cin into ntemp, and they cast it into an integer using stoi as usual. So we will be starting to implement the logic from line 17 onwards, and the first step, as we discussed, is to somehow represent this n as a string representation of n in binary. So before we do that, let's explore a new data type, or rather a class called a bitset. And this bitset, in this case, the parameter to bitset over here will be the number of bits that you like. And in this case, I will be jumping the gun a little, but I'll be putting in 20 over here. We'll be using 20 bits to express up to 1,000,000 in decimal. And let's give this a number of my bitset. Let's set this to be equals to bitset 200. Let's call the constructor and pass in n as the parameter to this constructor. And just like that, we have my bitset over here. If you were curious why we use 20 over here, that's because 20 bits is just sufficient to express a decimal number up to 1,000,000. So to really understand the thought process of getting here, let's quickly go through how many states can a single bit represent. So a single bit can represent 2 states. So if you have 1 bit, then you can express either 0 or a 1. If you wish to express 2 and 3, which is our 3rd and 4th state, then in this case you will have to throw in 1 additional bit. And to be specific, if you want to express 2 bits, then that would be 00, 01, 10 to represent 2, and 11 will represent 3. So you can roughly see the pattern. The number of states that we can represent with bits, where n is the number of states you want to represent, n is equals to 2 to the power of n, where n is the number of bits you have. So to let you better understand how to express decimal numbers in bits, let's quickly try to do that for the first 11 numbers that we have over here. So for 0, that's 0 in binary. For 1, that's 1 in binary, because we only have 2 states thus far. 2, in this case, will be our 3rd state. So we cannot use 1 bit anymore. So that will be 10. 3 will be 11. 4, in this case, will be our 5th state. So 2 bits won't cut it anymore. We have to throw in 1 additional bit to represent this additional 5th to 8th state. So for number 4, that will be 100. 5 will be 101, 6 will be 110, 7 will be 111, and 8 in this case would be your 9th state. So we have to throw in an additional bit again. In this case, it will be 1000, 9 will be 1001, and 10 will be 1010. But I hope that this exercise gives you a hint to the number of states that we need to represent up to 1,000,000 numbers. And to be specific, to express 1,000,000 numbers, you need 2 to the power of 20 states over here. So what this means is that you need 20 bits to represent that. And that is how we represented this. So that's pretty much it. So at this stage, we are sure why we use only 20 bits. And if you were wondering, okay, I understand that we need 20 bits, but why can't I just add in more bits than I would need then? Why can't I just set this to 100? Well, when you are in a technical interview, interviewers are not only looking for your ability to solve this question, they're also looking at your understanding of bits and also how you can cut down the number of bits as possible. And as we mentioned earlier, we'll be doing some linear scan across these bits as well. So the less bits you have, the more performant or the less bits that your algorithm would have to process. And this would let your runtime be way shorter for your implementation. So knowing that you need only 20 bits for this question would be a good way to impress your interviewer that, hey, you know things about your bits concepts and you're able to understand that 20 bits is all you need for this question. So I hope that cleared up some questions that you might have. So at this step, let's move on to the next step of converting this bit set into a string so that we can iterate over them. So let's define a new string. Let's call this my bitset string. This bitset string would represent the binary representation of your n, but in string format. So in this case, to do that, you can do my bitset.toString. This is an instance method on the bitset class object over here. So now that we have this bitset string, I guess it would bring more clarity if we print this out. So let's quickly see out this bitset string to the console. So here we go. If you are curious how many bits that we have, you probably might have guessed it, but this would represent 20 bits over here. And to prove that to you, I'll be printing out the length of the string as well. And as you can see, that is 20. The length is 20, that means we have 20 bits. So that's pretty much it. Now we're done with the first step. The next step will be to figure out how do we efficiently get the maximum number of consecutive ones in this string. And here I'll be introducing a new concept called two pointers. To be specific, we are using two pointers such that there is a left and right pointer. And the left pointer will be pointing at a current consecutive one window. And the second pointer will be pointing at the end of the consecutive one window. On top of that, we will have some auxiliary pointers as well. Let's call this current index. This current index would be separate from the two pointers, but this current index will be iterated from left to right. And only under certain conditions do we assign the left pointer to be a similar value to the current index. So on top of this current index that we iterate from left to right, this will be iterated from left to right. This left pointer will be assigned to current index plus 1 if the current character is equals to a current 0. So if this is current 0, then we will set left pointer to be equals to current index plus 1. Let me make this a bit clearer. Let's call this current index character. So what this means is, because if the current character is equals to 0, then it means that that is not a valid consecutive one window. So we're going to try our luck and assign left pointer to the index to the right of this current index, hopeful that this will be pointing to a 1. But if it is not a 1, then in the next iteration, this will be pushed to the right again anyway. So that's fine. For the right pointer in this case, that would be pointing to the end of your consecutive window. So the condition for this would be if the current index character is equals to 1. If that's the case, then we will set the right pointer to be equals to the current index. And when you update the right pointer, that means that your current consecutive window is lengthening. And we probably want to keep track of two variables. The first variable that we want to keep track of is your current consecutive window. This current consecutive window is the current length of your current consecutive ones window. And this will be updated every time when your right pointer is updated. So if right pointer is updated, then you set the current consecutive window to be equals to right pointer minus left pointer plus 1. And just to show you how this works, assume that you are currently looking at the 1 in the first index. Notice that your right pointer and your left pointer is pointing at the same index 0. Then your current consecutive window will be equal to 0 minus 0 plus 1. So that gives us the correct answer of 1. This is just to bring some clarity into why this current consecutive windows is equals to this formula. The next thing that we keep track of also when right pointer is updated is to keep track of a maximum cons window. When you are iterating the string from left to right, you will likely encounter multiple consecutive ones window, but we only want the maximum. So what this means is maximum consecutive window will be equals to the max of itself together, max together of itself and this current consecutive window. Notice that the current consecutive window will be overwritten as we move the right pointer. Same for the maximum consecutive window. So the idea is with one single linear scan and with this two-pointer strategy of keeping track of your left and right pointer, which will point at your current consecutive window as you move from left to right, we consistently check our current consecutive window length and we just update our maximum consecutive window with that. And by the end of your linear scan for your current index from left to right, you should get your maximum consecutive window after this algorithm. So I hope this gave you some clarity into the approach, but if that was not very clear, I hope the implementation coming up would give more clarity into that. So with that, let's get started. The first thing I will define is the current consecutive window. This will be equal to 0, maximum consecutive window. Let's assign this to 0 as well. I forgot my semicolons. Left pointer will be equals to 0 as well, and our right pointer will be equals to 0 as well. And once we're done, we can start iterating. Our sorry, I came from the land of snakes, so having a little bit of brain damage over here. Let me just change this. Okay. Oh, if you're wondering what the land of snakes is, I'm talking about Python. Now we have current index. Let's set this to 0, and we'll be iterating current index from left to right. So in this case, we'll be iterating from the length over here, from the length of the bitset string over here. Let's delete that because we do not need that in our output. And let's increment current index by 1 after every iteration. So at each iteration, our job is to check the contents of the current character. So if my bitset string current index is equals to 0, then what this means is that we are not pointing at the current consecutive window as we discussed earlier. We will set the left pointer to be equals to current index plus 1. If that is still the case in the next iteration will take care of that and shift left pointer to the right again. If the current index is pointing at a 1, then what this means is we can update our right pointer to be equals to the current index, and this is also our chance to update our existing current consecutive window. So let's set current consecutive window to be equals to right pointer minus left pointer plus 1. And once we're done, we can update our maximum consecutive window with the max of itself together with this current consecutive window. And that's pretty much it. So at this step, you should be given the maximum consecutive window after this linear scan. Let's run this against some test cases. This pass. Let's submit this. And there we go. I would say this question is quite difficult compared to the previous challenges that we experienced thus far. And to be specific, this question I would say is pretty close to an easy level technical interview question. So if you felt that this question was a little hard, do not be disheartened, it's a process. And this question, I guess, introduced a very common tactic when it comes to dealing with strings and array questions. And that is the act of using two pointers, or as somewhat like a sliding window where you slide the window, and this window represents a certain business logic that you are concerned with. And to be specific for this question, the so-called business logic is to keep track of the consecutive ones that we are keeping track of as we scan this string from left to right. So I hope that this was a good introduction to expressing a decimal number in bits, and also be comfortable with this new concept, 2 pointers. And that's all for this question. If you find this useful, please give us a like and subscribe, and we will see you in the next video.